some minutes to present a Okay. Today I will present my research entitled ULOV8-based system for agriculture harvesting optimization, the case of potato tuber seed selection. This study focused on the application of artificial intelligence in the domain of agriculture. So in introduction, as we know, the second Sustainable Development Goal defined by the United Nations is Zero Hungry. This goal aims to end hunger, maintain food security or achieve food security, improve nutrition, and promote the agricultural sustainability. For our country, agriculture and food security are one of the major areas that the state intends to promote in the Algeria 2030 vision, along with industry and energy, because it has a direct impact on the economic indexes, like the volume of importation and the volume of exportation. Also, direct impact on the product prices in Algeria markets. So, the Algerian government strategy for food security and sustainable agriculture and agri-food technology focused on three baselines. The first one is large-scale harvesting, which means to support or which aims to support the harvesting, the extensive harvesting operation in southern region. The second baseline is digitization, which means the transformation of data from classical format like document, paper, etc., to digital information. The third one is digitalization, which means the use of advanced technologies to automate and optimize the agriculture and post-agriculture harvest, or to optimize the harvesting and post-harvesting process. And of course, data science and artificial intelligence are the core of these advanced technologies. Moving to the problematic, as we know, potatoes represent one of the Algeria's most consumed and cultivated crops, but sorting and seed selection of these products remain mostly manual and inaccurate, which lead to several disadvantages and problems like time-consuming, yield losses, intensive use of chemical and fertilizer, and finally leads to unstable production. So, as a solution, we propose to using artificial intelligence to automate the selection process and optimize the quality of the selected potato tuber seeds. The primary goal of this work is to propose a computer vision method based on ULOV8 to classify and select potato tuber seeds according to the optimal selection criteria defined by the domain expert and research. So, in our work, we focus on two criteria or features as we named in artificial intelligence. The first one is the shape, where we analyze or we evaluate the shape of the potato tuber seed and detect any surface defects. The second criteria is the potato eyes, where we count and assess supporting eyes for viability. What is ULOV8? ULOV8 is there is some image don't isn't there. 1 minute. There is some image doesn't present it. There is some image doesn't present it in the Donc, on a continué sur des images. Alors, ULOV8 is a computer vision technology or AI technology developed by the Ultrasec Corporation. It's used for object detection and instant segmentation. It's architecture based on deep learning models, especially CNN, convolutional neural networks. It's characterized by its lightweight deployable model, which makes it suitable for small devices, and real-time processing, which that allow for continuous detection and classification process in real world. We move now to the method and materials. The first phase of our methods is creating a data set where we collect our data from 3 different open data sets. It's available on Kaggle platform. These data sets are used as data resources. The second step of the construction of our data sets is about performing a data cleaning and processing using Python programming language and its specialized frameworks in this task. The third step is data labeling, annotation, and augmentation, where we use the RoboFlow tool. Now we discuss the model training and fine-tuning process. Here in the image, we show the tasks that we need from the machine learning do it. In the image at the right, the model should detect the body of the potato and classify if it's a normal or abnormal shape. The second image at the left represents the task that we need from the ULOV8 performance, which is the detection of potato eyes. The code below presents the configuration of our model, where they contain 4 principal sections. The first section is about the upload of the model. The second section is about the call of the model responsible for retraining the model on our data. The third section is about the specification of our dataset file. And the last section is the fine-tuning or the configuration of our hyperparameters. So, for the results, as we see in the chart in top, the model is training with success, where we show a decrease of the loss function. That means that our model is learning with success. Also, the performance of our model is increased in the bottom figures, which means the learning process is performed normally. This figure is about the learning curve of potato-shaped classification tasks. And the same thing for the learning curves of potato eyes detection. Although the loss function doesn't achieve the optimal value, the performance metrics show a high rate, where we observe that the model achieved 40 or 94% for both models, and for precision performance metric, the model achieved 90% for the classification model and 96% for the eyes detection task. For the mean average precision, the model achieved 95% for the task of potato shape classification and 97% for the task of eyes detection. This image illustrates that or shows that our model work correctly, where we show that the model detects normally the potato bodies and classify them to normal and abnormal potatoes. The same thing for this validation sets. The model work normally and detect the potato eyes with high precision, as we see in the image. So, summarizing our contribution, the first contribution of this work is tailored YOLO implementation for agriculture automated sorting and precise selection methods. Enable or incremental training methodology, enabling continuous learning approach, ongoing model improvement and adaptation. And the third contribution is a sustainable impact on the field of agriculture, where this work has a direct contribution to the sustainable agriculture precise through intelligent optimization and resource optimization. In conclusion, our research provides a fundamental step toward transforming traditional farming practices through cutting-edge artificial intelligence. The future work will focus on enhancing the selection criteria. The second step will focus on provide IoT and robotic prototype. And the third one is applying this model on different crops like tomato and other wide consumed products in our country. The expected outcome of this system is to enhance the seed bank of our country and the quality of our seed bank, and improve products return through precise classification. Thanks for your attention and welcome for your question.